Hello, my name is Nigel Griffiths. I work in the Advanced Technology Group, part of IBM Europe. In this Back to Power Basics movie, we're going to be looking at the Virtual I/O server and the principles behind it and how to make best use of this feature, which is part of Power VM. We're going to be looking at the principles, what's the value of it, practice about how to update it and manage your VIO server, and where to get more information. Then we'll look at the trends and directions of where the VIOS has been in the recent past and where we're going in the future. Now, the value of the VIO server we're going to cover in 4 diagrams here. The first, maybe the most important, is an economic I/O model. If we can imagine on the left hand side here, each logical partition will have its own adapter. Maybe we'll actually need 2 adapters for resilience and redundancy, and maybe we need 1 adapter or 2 adapters for the network and 1 adapter or 2 adapters for the disk I/O. But we'll ignore that duplication for the moment. Let's say we have 8 logical partitions and 8 adapters. But we find with these small logical partitions we can't keep a modern high-speed adapter fully used. So maybe some of these logical partitions are only using 10% of the throughput of those particular adapters. Now on the right hand side, if we put just say a pair of adapters into the Virtual I/O server, all of the logical partitions here can use that pair of adapters. We'll be getting a higher utilization here, maybe 40%, and on the VIO server we can use multipath I/O to share the load across the 2 adapters. So we still have resilience in here, but we actually have a lot less adapters, and if you look at the price of adapters you'll find that's quite high if it is high performance adapters. So we're actually going to save quite a lot of money. So instead of looking at the question, why would I want to use the Virtual I/O server, we should flip the question over and say, how can we possibly think of not using a Virtual I/O server? We're going to cut down the number of adapters. That will save money. We could perhaps actually get all the adapters into the smaller machines, or we could not have to buy an extra remote I/O drawer, so that's going to save us money. In the Virtual I/O server we can have further redundancy than we can do with lots of individual logical partitions, and when our logical partitions go busy, they're now connected to a larger pipe coming out of the Virtual I/O server. In the left hand side, if we actually used a full adapter we couldn't actually go any faster. But if we're connected to a Virtual I/O server that has 2 or 3 or 4 adapters, we can actually go a lot faster by using the Virtual I/O server. So the question is, how can you contemplate not using the Virtual I/O server? Next is the reduced infrastructure. If we only have a pair of adapters, we only need to run 2 cables to the back of the machine to maintain our I/O for network and perhaps 2 for the disks. That means we're going to not have lots and lots, dozens of cables, and it also means that we don't have to plug in the other end of the cable into lots and lots of either SAN networks or Ethernet network switches. Now, if we actually take up a lot of switch ports, we actually have to end up buying more switches, and the switches themselves can cost quite a lot of money. And then we got to power up those switches, and some of those can actually run quite hot and take quite a lot of electricity. Now for the Power 6 machines that I use at IBM, I find it's really nice to be able to run a pair of cables to my new Power 6 machine and know that all of my logical partitions, maybe 10 or 20 logical partitions, are now all cabled up in one go, rather than trying to plug in 20 Ethernet cables and 20 fiber channel cables and run all the cables across the machine over to the switches. Again, this reduces our costs and complexity. Next, of course, the Virtual I/O server allows us to share out resources without actually having to go to the machine and plug in new adapters or new cables. So we can actually move to have quick deployment of our machines, and we can say we can create another logical partition, allocate some virtual disk space, allocate a virtual network, and have that up and running in a few minutes. The alternative, where we might have to purchase stuff, get it delivered, get it commissioned into the machine, and then start configuring it, we can take a lot longer. And perhaps you'd like to say to your customers, we'll have this up and running in 20 minutes rather than 20 days, which can really annoy a lot of our user department. Also, we find that particularly in some industries, that time delay costs some serious money. If the logical partition is being used for some market intelligence type reasons, or to be able to find a gap in the marketplace where we can actually make further profits, that delay of 20 days can actually cost several $1 million or euros. And lastly, the virtual I/O server plays a big part in server consolidation, taking dozens to hundreds of smaller, probably older machines and consolidate them all into one larger machine for shared resources. This also has an impact on the energy used in the computer center. And the bulk of the energy saving we have by using the power-based machines is this server consolidation. Perhaps 80% of the power we can save is part of the server consolidation. There are some further tools like the Active Energy Manager that we can switch on to further reduce the power that we're actually using in our machine, but we have to admit that the bulk of the saving is due to server consolidation in its own right. So we mustn't neglect that feature to actually save a lot of electricity and in the end a lot of money. Now in practice, the virtual I/O server runs as a logical partition and it's delivered as an appliance. We can see a picture here of another appliance that we can readily understand, a toaster. Now we're only allowed to log in as the root user to install particular approved disk device drivers on the machine, and we're banned from any other AIX type features like NFS or NIM or running a website or running a backup server on our virtual I/O servers, and we're quite strongly discouraged from logging in as root. Now this has resulted in a very low problem rate on the VIO server. Inside IBM I could look at this database called Retain and look at the issues that people have had with the VIO server, and it is surprisingly low. This simple appliance mode of supplying the functionality of the VIO server has actually done us a lot of good. It proves perhaps that it's people fiddling with AIX that causes a lot of the problems, because if we discourage people from fiddling with AIX, or the VIO server in this case, then it just tends to run and not go wrong. It also highlights the fact that we can create a few problems with the VIO server, perhaps some are self-inflicted. So we don't recommend you go below a gigabyte of memory in your VIO server, for example, and that you should be using a shared CPU and leaving it uncapped and giving it a couple of CPUs as virtual processors so that it can take CPU time if it needs it. But we can also make use of that CPU time if the VIO server is not having to use a lot of CPU time. Now, having said its appliance, the VIO server does need regular updates. If you've signed up for the support, then we support up to 2-year-old versions of the VIO server. Now, if you have a problem and there's a defect and we need to produce a fix for that, we will only produce the fix for the latest version of the VIO server. So if you want that correction, you will have to upgrade when you've hit this problem to the latest version of the VIO server, which is currently 2.1. Now, if you have a non-defect support, perhaps your VIO server has gone wrong in some way, or you need help with a command, or you've lost track of something in the VIO server and you want the support people to work through and find how to connect these things back up, then you can still do that with up to 2-year-old versions of the VIO server. Currently, when I've recorded this video, then the VIO server 1.3 is the oldest version that we'll actually do non-defect support with. But that will be moving to 1.4 in 2009. But we strongly recommend that as we have an update twice a year, typically in November and May, that you keep your VIO server under a year old, and then you have less problems. It also means that you're getting all those latest fixes and performance improvements as well. Now the whole point of having a dual VIO server mode is so that you can relatively painlessly upgrade your VIO server. So you might as well do it, as you've already paid for the dual VIO server working. Now the fix packs are downloadable from the website, and that'll come up on the next slide. And because we're not running anything else on the VIO server, updating it should not really be a problem. And just like our toaster here, a toaster is an appliance, but it does need regular maintenance. Now, you are expected, perhaps once a year or once every 6 months, to empty that crumb tray at the bottom of your appliance. Just because it's an appliance doesn't mean that it doesn't need maintenance. At the bottom here we have the website where we can get the information from the IBM about the virtual I/O server. And in particular, this page here shows us that first of all we have the download link. This is where we get the updates. We have the latest README here, so you can see what the improvements are in the latest version. I quite often get asked about, does the VIO support this sort of disk or this sort of operation, and we can see a link there to the datasheet. Now if the disks you want to attach to your VIO server are not on that datasheet, then they are not supported. Now if you do have some disks that you want supported, do get in contact with us, and if there's sufficient demand, we'll try to add that to the testing schedule for each VIO server as it comes out. Now, we can't promise that, but if you don't let us know, then we won't know that there's a demand out there. There's also a list here of the Red Books, which are good for the VIO server, and the online manual page and the command reference manual, which are actually quite difficult to find any other way, so it's a very useful link there. At the bottom there's a series of white papers with some fascinating extra information on particular parts of the VIO server. So here's your reference library. These are my top 4 Red Books on the virtual I/O server and the hardware management console, because we work on typically on the HMC to do a lot of the virtualization. And again, we either have the hard copy of the operations guide and the manuals, or we have them available online. Now we're going to look at a little bit of history about the virtualization that we have with the virtual I/O server, and from there we can see where the trend is going. Now back before the year 2000, people were buying lots of separate machines to run separate workloads. We've been doing that for quite a while, and everybody got very used to that. Then in 2001, IBM introduced the Power 4 range of machines, and these had logical partitions, and we could start doing server consolidation, pulling workloads together so that they could share resources, and when we could change the boundaries over time for a lot more flexibility, and reduced the size of the machines. Then in 2002 we introduced the dynamic LPAR, where we could live change the boundaries between the logical partitions. So we could add a CPU from one logical partition and give it to another, or we could move some memory between the two logical partitions. We can do this manually on the HMC, or we could write a script to do this at particular times. Then in 2005, when we introduced the Power 5 machines, that's easy to remember, 2005 and Power 5, we started using the shared processor logical partitions. This is where the hypervisor inside the machine, at a sort of millisecond level, moves the CPU power to the logical partition that really needs it. And this actually allows us a couple of things. One is to run more logical partitions on a machine, and it means that we can boost the performance of logical partitions so they get extra performance when they actually need it. Let's move that over. In 2006 then we introduced the idea of harvesting. You'd look at your shared processor logical partition and find over time, maybe 3 months, maybe 6 months, or maybe longer, you find that you're never using all of the capacity inside your machine. That capacity isn't actually being used, and you can add more workloads, more logical partitions to the same machine, and harvest what you've already purchased but are not yet using. This allows you to run more workload with zero extra hardware cost. Then in very end of 2007 and 2008, we're now getting into partition mobility. This allows us to jump a workload from one machine to another machine without interrupting the actual work going on inside the logical partition. So the users will be unaware of the fact that we've moved the logical partition between them. We can do that for a number of reasons. First of all, we may want to move it to another machine that has more compute power available, so we can boost the performance of a logical partition. Or maybe we want to take all the logical partitions off a machine because we want to do some routine maintenance on the machine. Another way of looking at the virtual I/O server and the logical partitions is that a logical partition is a CPU engine that's driving I/O. It's either doing network data coming in and out, or it's doing I/O to the disk subsystem. And so let's look at that I/O-centric view of the world. In the past, when you've had separate machines, as we were looking at earlier, then every logical partition or every workload had its own network adapters and disk adapters. That moved on when we had the virtual I/O server, where we can then use the virtual I/O server adapters on multiple logical partitions. So here at the bottom we can see we have two logical partitions using the VIO server. They no longer do direct I/O themselves, but some of perhaps the larger and production logical partitions still using direct I/O. In phase 3, people moved over to nearly everything using the virtual I/O, except for perhaps some very big databases that have a high I/O throughput requirements, and they're still running with direct adapters. These days, though, most people are opting to go pure virtual, so that all of the logical partitions are going through the VIO servers. I was recently involved with a large SAP requirement, and here they had 24 CPUs required to drive the application, and we went through the process of deciding how big the VIO server would have to be to maintain those I/O rates. And the higher I/O rates were something like 30,000 IOs a second, and it sounds like a big number. And when we do the maths that's available in the Redbooks, we can see that the virtual I/O server is coming in sort of a maximum of about 0.4 of a CPU to do that I/O. Now the designers and architects for the system said that's just fine. They really would like to go with the virtual I/O. It's a very small requirement compared to the overall requirement for their application, and they really want the added benefits that going pure virtual actually gives us, and we'll look at those in a second. Now in this picture here, I've got across the top the virtualization of the processor, and then down the side we've got the virtualization of the I/O, the disks and the networks. And people started off here at A1, and then we'd be moving across this picture. And the idea is that we want to aim most people to go to the bottom right of this picture. I find that most people are happy virtualizing their CPU and doing dynamic LPAR changes, and then they, when they have more confidence, they move over to start implementing more of the virtual I/O server to do their I/O, and eventually they get down to the bottom right. Now at that bottom right we have pure virtual CPUs, and we're doing everything with the virtual I/O server. And in that bottom right square then we have the partition mobility, where we can jump a logical partition from one machine to another. And this is the trend and the direction that we're going in with our virtualization technology. And most people, that if they're starting fresh, actually start somewhere down in that yellow triangle, and they want the features of partition mobility to give them a great deal more flexibility. And I'd encourage you to work out how you can actually get there and move in that direction. Well, thank you for watching this movie on the Virtual I/O server and the principles, the history and the trends of where we're going with our virtualization. In the next movie we'll look at the Virtual I/O server 2.1 and the new features available with it.